Compound inequalities. These are inequalities using the logical operators and or. And all we really need to know about these compound inequalities is that if we have an and statement, we automatically know that we're going to take the intersection of the solution sets. If we have an or statement, we automatically know that we want to take the union of the two solution sets. So looking first at our and statement, let's go ahead and graph these. X is greater than 1 and x is less than or equal to 6, so let's mark both 1 and 6 on our number line and graph x is greater than 1, and let's also graph x is less than or equal to 6. And since this is an and statement, we know that we want to take an intersection, which is the overlap, so we can fill in this overlap region as the part that's our final graph, and then we can write that using interval notation as the interval from 1 to 6 with a round parenthesis at 1 and a square bracket at 6. Going on to our or statement, let's go ahead and graph these two sets. X is greater than 4 or x is less than or equal to 1. Greater than 4 looks like this. Less than or equal to 1, square bracket, and off to the left. Since these are disjoint intervals, our union is going to be the union of the two intervals. So this is from negative infinity up to 1, square bracket, union, start over again at 4, up to infinity. Note that we only write this as a union using the union symbol if they are in fact disjoint intervals. If there's any way to write the union as a single interval, we have to do that. This union symbol to combine two intervals is only allowed if it's the only way to write it. Another thing that's rather important about these to mention is that an and statement can be written in this compact form, and an or statement cannot. To see how this relates to the statement that we have using an and statement, if we swap the order of the first inequality, instead of saying x is greater than 1, it would say 1 is less than x, because of course we have to flip around that inequality symbol along with the statement. So we have 1 is less than x and x is less than or equal to 6. When we have this all kind of written in a row like that, we can see that this x and x that's kind of in the middle can just merge and become 1x, so that it reads 1 is less than x, which is less than or equal to 6. But if it's written in this compact form, then it is automatically an and statement. Even though it's physically possible to do the same manipulation on these statements that are combined with an or, it is no longer a valid statement. It is absolutely implied and anytime it's written in this compact form. So with this in mind, we're going to go on to this list of compound inequalities and change them from set builder notation to interval notation. We'll draw a quick graph for each one. It's not always necessary to draw a graph to do this, but it is helpful. So here we have negative 12 and positive 1. We've got x is greater than negative 12 and x is less than or equal to positive 1. Because this is an and statement, we know that we want the intersection, which means we want the overlap, so we see that yes, in fact, this is just the interval from negative 12 to positive 1. Going on to the next one, again we have an and statement, so again we will be taking an intersection. We have 1 and 6. We want everything that is less than or equal to 1, so from 1 it goes to the left, and everything that is less than 6, so from 6 it also goes to the left. The intersection is the overlap of these two graphs, so I'm just going to shade in the region where they overlap, and it looks like both have arrows, so our intersection will also have an arrow. The value 1 is included. I'm going to put a square bracket on that because the value 1 is in both sets. So this is the interval from negative infinity to positive 1 with a square bracket on 1. Next we have the values 0 and 9. We need to write these in order. And let's just look at these statements one at a time. First of all, x is greater than or equal to 0. That shows that we're going from 0 to the right. Let's choose a different color for the other one. The statement 9 is greater than x. It's easier if we read this backwards as x is less than 9. We don't necessarily have to write it down again, but just reading it backwards is sufficient. So we say, okay, yes, it looks like from 9 we're going to go to the left. And we know that because this is written in the compact form that it must be an AND statement, and therefore, again, we want the overlap of the two solution sets. Square bracket here at 0, round here at 9. So this is from 0 to 9. Going next to our first OR statement, we have 3 and 11. X is less than 3, or x is greater than 11. Since this is a union, we're going to take both of these disjoint intervals and combine them with a union symbol. So this is from negative infinity up to 3, union from 11, whoops. Okay, and then from 11 to infinity. Going down to our last problem, we have x is less than or equal to negative 4, or x is less than or equal to 11. So let's mark these in order, negative 4 and 11. So less than or equal to negative 4 is to the left. Less than or equal to 11 is also to the left. And the union is everything that is on one graph or the other, so we just start here and it looks like we keep going. We do want a square bracket here also, matching the bracket of our original. And we're going to express this as the interval from negative infinity up to 11, square bracket. One of the more common mistakes is to just follow the same pattern for everything and to think that we can just write this as negative infinity to negative 4 union negative infinity to 11. And even though it might feel like this is accurate, this is not a valid interval notation. This is a problem that's not done yet, because it is possible to actually take this union and write it as just the interval from negative infinity to 11. So make sure that when you take your unions, you're not just taking the two sets and putting them each in interval notation and putting a union symbol between them. Make sure you are taking the time to think about what that set actually contains and writing it in the most compact possible interval notation.